Everyone, in today's lecture, I'm going to explain you the wind load that are that comes in the topic under the topic design of RC structures. Okay, so here I'm going to solve a numerical for you. So the particular information of the numerical is given here. Here you can see that the height of story is 3 meter. That is given to us, and then again height of structure is uh, actually the height of total height of structure is not given, but I have calculated it by multiplying the number of story to the height of each story. So by multiplying this, number of stories are given to us that are 10. Okay, and height of each story is 3 meter. So here you can see that the total height of the structure be 30 meter. Okay, so now the location of the structure is in Dehradun. Okay, so the area in which the structure is lying is in Dehradun, and design life of the structure is 50 years. So, and the category in which the structure is fall, that is third category. And now the information about the topography. Okay, that is the angle which is it is having, that is less than 3 degree. So theta is less than 3 degree, which is given here. Okay, and the beam size, that is 250 into 250 mm. The column size is 450 mm. So generally you can see this is a square beam and a square column. So now moving further towards the plan of this building, of this structure, here you can see that the plan of this structure. Here you can see in this diagram that this is the launch, this is the lateral. Okay, so it is the lateral direction, and this is the longitudinal direction. So, and this is called the bay width. Okay, so here you can see the center to center spacing between the columns of the center to center spacing of the two continuous columns. Okay, this is known as bay width. Okay, bay width. So now here you can see that the bay width for longitudinal direction, that is 6 meter. Okay, and for lateral direction it is 5 meter. So the bay width for lateral direction, that is 5 meter each. This is the bay width for lateral direction. Okay, and this is the longitudinal bay width. Okay, so now let's move toward the question that we are having right now. Okay, so let me just change the slide. Here you can see that this is the very first step. Okay, this is the very first step that we are just taking here for this particular numerical. Here you can see that we have taken the wind speed. Okay, so for in the first step we need to calculate the design wind speed. So for this we need to calculate calculate the value of this formula. Here you can see that the vz, that is known as design wind speed, that is equal to vb into k1 into k2 into k3. Here you can see that vz is equal to vb into k1 into k2 into k3. And now I will tell you that from where we can easily find these values, the value of vb, k1, k2, k3. So first of all we would find the value of vb. So as I told you that vb is the basic wind speed. So let me just move towards a code that we are having here right now. Okay, so in this code, yeah, so from here appendix A, you can see that the location of our structure is in Dehradun. Okay, so we would find you can find this annex 1 in page number 96. So for Dehradun you can see that it is 47. the next constant, that is k1. We can find the value of k1 from, you can see that I have already taken the k1 value is 1. So this value is taken from table 1. Now let me show you that from where we can just find this value. So this value you can find easily on in this code at page number 23. Okay, so just wait a while. So you can find it on the page number 23. So the generally it depends on the basic wind speed of the area. So as we know that uh, our basic wind speed is 47. Here you can see that k1 factor for basic wind speed. Okay, here you can see that the basic wind speed is 47 meter per second. Okay, that we have calculated. That is the basic wind speed of in Dehradun. And as we know that in this question, the date according to the data given here, the building structure design life is 50 years. So here you can see that for 50 years we would find the value of k1, that is 1. Okay, so here you can find the value is k1. So I hope it is clear that from where we I hope that it is clear to you that from where we can find the value of k2. Okay, so now again here you can see that I have calculated the value k3. Okay, so k3 again I have taken as 1. I hope it is very visible to you. The value of k3 I have taken is 1, and it is that is I have taken from the clause 5.3.3, theta is less than 3. Okay, as in the question it is given that theta is less than 3. So here in this code, so as you can see that it is clearly mentioned here, the effect of topography will be significant at a site when the upwind slope theta is greater than 3 degree, and below that the value of k3 may be taken to be equal to 1. Okay, so we are going to take the value of theta, sorry, k3 equal to 1 because theta is less than 3 degree. So for the value of theta less than 3 degree, the value of 1 for k3 is considered. So again let's move back to our question. Here you can see, okay, so here you can see that we have calculated value of k1, k1, k2. Okay, so now we are going to calculate the value of k2. So for k2 we need to find we require to find uh, first of all let us draw the plan and elevation of the structure. It will help us to determine the class of building. Okay, so as given in our question that it lies in the category third. Okay, so it is lying in the category third. It is already mentioned in the question. So now we are just going to prepare a plan and elevation for this building. So to find the class, as I have already discussed here and already have written here. Now as we have already calculated the value of k1, okay, that we have find that is 1, and k2 that is also 1. Okay, so now we are just going to move further for the determination of the value of k3. So for the determination of the value, we need some we need to do some steps. Okay, so first we are just going to make a plan and elevation of the building according to their dimension that are given to us. So now some of the points we should keep in mind while determining the value of k3, that to determine the class of building we need to first Here you can see that as I have make a plan and elevation of this building. So here the greater dimension, as you can see that in this building, in these building structures, here you can see that these are made these have different dimensions. Okay, so the greatest dimension among all these are is 30 meter. Okay, so as you can see that 30 meter is the greatest dimension. So we are going to compare it with the value that are given by the codes. So here you can see that greater dimension of building is 30. So if the greater dimension of building is less than 20, so it will lie in the class A. But here you can see that our structure is not less than 20. So we are going to move to our next condition. Here you can see that greater dimension lie between 20 to 30. So the building will lie in class B. So it is satisfying our condition, that is 30. So 30 meter is our greater dimension. Okay, so it is already lying in the 20 to 30 20 to 50 meter uh, dimension criteria. So it will lie in the class B. So now here now so we are able to find the class of building. So moving toward the next slide, you can see that as I have already mentioned, as I have already find the value. Okay, so now it is time to find the value of k2. And let me tell you something, that as we have as we have known, as we have known the category of this building. Okay, as we have known the category of this building, that is 3, that is 3 meter. Okay, and the class of this building is B. So from the code we can find the value of k3. So moving to our code, here you can see in our code the value of k3 is clearly mentioned. K2, sorry, the value of k2 is clearly mentioned in page number 24, table 2. Okay, so let us scroll down. Here you can see the value of k2. As we know that our building category is 3. Okay, our building category is 3. Okay, and for the value of k2 we need the maximum height of our building is 30 meter, that we have calculated before. So here you can see that the maximum height of our building is 30 meter. So here you can see that the value of k2 is varying at each height. Okay, for 15 meter it is 0.97, for 10 meter it is 0.91, for 20 it is different, for 30 is different. So now we will just draw a table from this code. We are going to uh, take the needy values that we would require. Okay, so we will form a table. So we will form a table here that we have already calculated. So moving toward the next slide. So here I have taken from the code that I have taken the value of, here I have the value of, at a height of 10 meter, the value of k2 is 0.91. Okay, 0.91 here you can see. And for the height of 15 meter it is 0.97, for the height of 20 meter is 1.01, for the height of 30 meter it is 1.06. So in order to make our calculation easier, because we know that we have the to design wind speed sorry design wind speed, that is vz. So here we can easily put the formula and find the different values. Okay, but here you can see, here you can see just Now here you can see that we have taken the values for K2, and but here you can see that the value of K2 is keep varying for different height levels, so it will definitely uh, give a effect on the value of Vz. So now we are just calculating the value of Vz for a different level of height. Okay, so first we will calculate for the height of 10 meter. So for the height of 10 meter, the value of Vb will be constant. Okay, and the value of K1 is also constant. Okay, because it doesn't have any relation to the height of the building. And the value of K2 is varying as we have already discussed. Okay, so the value of K2 at 10 meter height is 0.91, at 15 meter it is 0.97, for 20 meter it is 1.01, and for 30 meter it is 1.06. Here you can see that we have taken all the value of K2 from this table, and this table we have taken from the code. Okay, so the value of K3, here you can see the value of K3 is also constant. It doesn't have any relation to the height of the building. And now after putting all these values in a formula, so for a particular height of 10 meter, okay, you can see that for the particular height of 10 meter, by multiplying all these value, by putting them in this formula, that is VB into K1 into K2 into K3, our final value for the particular height of 10 meter, that is 42.7. For 15 meter it is 45.59. For 20 meter it is 47.47, and for 30 meter it is 49.82. So here you can see that our the whole value depends on the K2, because K2 is keep varying. Okay, so K2 is keep varying here, so it have something related with the height of the building. So now we have find all the values, that is design wind speed. Okay, so now we will move towards our second step. So in the second step we are going to find the design wind pressure, that is denoted by Pz. Okay, so the formula for the calculation of Pz is 0.6 into Vz square. Let me just write it for you so you will not be confused. It is 0.6 multiplied by Vz square. Okay, so this is the formula for Pz. Okay, so here you can see that again here that we because we can't find the single value of Vz, because the value of Vz is keep varying from which we can see from the above table. Okay, so for the particular height we need to find the designed wind pressure. Okay, so now we will just take this table that is given, that is given. Okay, we are just taking the value of Vz from the above table. So for that particular height of 10 meter, here you can see that the Vz value is 42.7, 15 meter 45.59, for 20 meter it is 47.47, for 30 meter it is 49.82. So now from here you can put all this value in this formula. Okay, the value of Vz you can just put in this formula, and from here you can calculate the different value at different level of height. Okay, so if by putting this value in this formula, you can find that at the 10 meter height level the value of Pz is 1097.56. For 15 meter it is 1247.06. For 20 meter it is 1352. For 30 meter it is 1489. Okay, So now, as we have already find these values, let's move to our next step. So now, moving toward our third step, we need to calculate design wind speed, that is denoted by F, that is denoted by capital F. You can see now the formula for the F, or sorry, for the design wind load, that is CF multiplied by AE multiplied by PZ. So yeah, you already know that the CF is the force coefficient of building, and AE is the effective frontal area, and PZ, that we have already calculated before, the PZ is design wind pressure. Okay, so to find, first we will move the first step we will find here is the value of CF. So here you can see that the value of CF depends upon the ratio of A upon B and H upon B. So now what we are going to do here is that we are going to make a plan and an elevation of the building again. So now this is the elevation, which includes, okay, which includes the height, okay, and and B, it is the width of this building. Okay, so now, and from the plan we can see that this is the plan of this building, which includes its length, that is 24 meter, okay, and the width, that is 15 meter. So now, as we have find the value of A upon B, so now just putting these values in this formula, that is 15 by 24, it is 0.625. okay, that is 0.625. For the H upon B ratio, we are just going to put this value in this formula, so we will get 1.25. So after, so now here the value of CF totally depends upon the ratio of H by B. So here you can see that the H by B value is 1.25. So now there are two condition arises. The first one is that if the H by B ratio is greater than 1, so we have to refer figure 6a, okay, and if H by B ratio is less than 1, then we have to refer figure 6b. Okay, so I will tell you that uh, in this code where we can find the figure 6a and figure 6b. Okay, what does it mean? I will definitely tell you. So now, according to this question, we can see that our H by B ratio is greater than 1. Okay, as 1.25 is greater than 1. Okay, so now we will be referring figure 6a. So figure 6a is provided in the code as the page number 66. Okay, so at page number 66 we will find these values. So as we are referring to the figure 6a, so now for 6a we need to find the value of CF. Okay, so for the value of CF we also need the value of the ratio of the value of A by B. So in this question, uh, the A by B ratio, okay, the A by B ratio here you can see that is 0.625. okay, so now A by B ratio A by B ratio is 0.625. okay, so here we will find the A by B. The here you can see that this graph is between CF and A ratio B. Okay, so for A ratio B the value is 0.625. Here you can see that the 0.65, it will definitely lie between 0.5 and 1.0. Okay, so just a slight bit uh, ahead, after 0.5 you can find this value. Okay, so it would lie something here. Okay, so for the value of CF you can see that it is above 1.0 and it will lie in between 1.5. So this is the line which is actually passing through the particular point, okay, where both values are uh, crossing each other. So it would be definitely around 1.1 or 1.2, but I think but generally we take 1.2. Okay, so moving toward a question again. So from that graph, from figure 6a, we would be able to find the value of CF, that is 1.2. Okay, so now just move toward our next step. Now we have to calculate the frontal area, that is AE, the value of AE, that we can find it by using this formula, that is center to center length of single bay width per meter. So per meter it means 1 meter. So uh, as we know that center to center length of single bay width. Okay, so as I have already mentioned in the question, okay, let me just show you that in the given question, in the given data, you can see that width the bay width, which I have already told you, that it is the center to center length between two continuous columns. Okay, so that is given to us, that is 6 meter. Okay, so our single bay width, that is 6 meter, but with this we have to calculate according to the per meter. So now we will multiply the value of 6, and as per the per meter criteria it would be 6 meter square. Okay, so now once after finding the value of A, so now we have each and every value that we would be requiring to put this in formula, because CF we have calculated, that is 1.2 from the previous steps. Okay, and AE we have find, that is 6 meter square, and PZ that we have already find for different level of heights, where you can see that the value of PZ is different for different level of heights. So now here you can see that for the height level of 0 to 10. Okay, so for the height level of 0 to 10, it is 1097.56. The value of PZ is 1097.56. So now putting the value of PZ in this formula, you can see that CF is 1.2, AE is 6, and PZ for this height level from 0 to 10 meter, that is 1097.56. So on multiplying all these values together, we would be able to find this value, that is 7902.43. So for different level of height we would be able to find the different value of F. Okay, that is the design wind load. So for different level of heights, again for 15 to 20 meter, that will be 9734.688. For 20 to 30 meter level of height, that will be design wind load will be 10722.32. So now converting the whole value into kilonewton per meter. Okay, so we would simply divide this value by 1000. Okay, so on dividing the value by 1000, we would be able to find all the values in kilonewton. so so now from the above table we are able to find the value of design wind load for different level of heights. So now what we are going to do here is that we are going to place a diagram for these in order to understand these in a much better way. So these are the value of design wind load, and this is the diagram which we have just prepared by using these values. So here you can see from this table I'm just going to make this diagram again here. Okay, so you would be able to learn that how I was able to find them. Okay, so now uh, so this is the table. So this is the table of values. So now by using this table you can find easily draw this pressure diagram. Okay, so what we are going to do here is I'm just going to show you that first with the help of these values you can easily draw this diagram. So first what we have to do, first draw a simple straight line. So for a particular level of height, the first level of height is 0 meter. Okay, so we are just going to mention it here, that's 0 meter. The second level of height is 10 meter. Okay, and third one is 15 meter that we are going to mention. The fourth one is 20 meter, and then again the fifth meter is 30. Fifth one is 30 meter. So here you can see now we are just going to put the values of design wind load. Okay, so one by one we are just going to put. So now here you can see that for the value of 0 to 10 meter height level, that it is constant, that is 7.902. So here we, with the help of a scale or ruler, you can just you can just draw it. Okay, so taking the scale of 7.902, you can take it on the scale, that is 7 centimeter, or like 0.7 centimeter. Okay, so what we are going to do here is, after that, by marking it, try to join it. Okay, because it is a constant value up to 10 meter. For 0 to 10 meter level of height, the value is 7.902. Then what we are going to do here is that we know that our value of f is changing for a level of 10 to 15 meter. So as we know that for 10 meter it will be 7.902, and for 15 meter it is varying again, that is 8.978. So here you can see that I'm just going to again, with the help of ruler, you can just create 0.8 centimeter line. So now again join it from the level 10 to 15 meter. So after joining it, now you can see that after the 10 to 15 level of height, again the value is changing from the level 15 to 20. Here you can see that for the value of 15 to 20, it is 1352. As here for the level of 15 to 20 meter height, the value of f is 9.734. So uh, with the help of scale, you can just draw a line of 0.9 centimeter. Okay, so this is the 0.9 centimeter. So now again join the levels 15 to 20 meter. Okay, so now for the height of 20 to 30 meter, you can see the value is again varying, that is 10.722. So with the help of your scale, you can just draw the line of 1 centimeter. Okay, but it should be keep in mind that the value of the upper height, okay, there should be some difference in the level of these lines which we are just connecting here, so it would look like that our the value of f is gradually increasing. So now, after joining all these lines, now start putting the values, like from 0 to 10 meter height level. The value of f is 7.902. So as you have already seen here, for the particular height, for the particular level of height, you can just mark it for the different one, that is for 8.9978. This is the level for 8.978. And for again, uh, for the level of 15 to 20 meter, this is the 15 to 20 meter level. And for the 20 to 30 meter level, this is the 10.722. So these are the levels, and this is the pressure diagram which you can see on your screen. So now, moving toward our next slide, here you can see that this is the last step, or we can say this is a final table which we are just going to prepare, that we are going to find force at each story level. Okay, so in this table, we will find the force at each story level. Now we will prepare a table uh, for the different story number. Okay, so here you can see that these are the story number, that is first story, the second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So as we know that our loading level would be, like for the first story, our loading level would be 0 to 3 meter. As we know that the total height of our story, for one story, the total height is 3 meter. Okay, so for 3 meter, dividing the 3 meter height, okay, dividing this 3 meter height into for the height of each meter. Okay, so we are just going to calculate the value of force at each height of 1 meter. So for the height of because we know that first story consists of a 3 meter height. Okay, so the 3 meter will be divided into three parts, so each will be having 0 to 1 meter height. Okay, 0 to 1 meter height. The second one is having 1 to 2. Okay, let me just erase it for you. The second level, the second level is the first level is 0 to 1. Okay, 0 to 1. The second level is 1 to 2, and the third level is 2 to 3. So these levels are all consist of the first story. These all levels comes under the first story. So similarly, the other stories are also uh, divided into different parts. Okay, so now I'm just deleting all these marks. Now, one by one, we are just going to put the values which we have previously calculated. From the previously calculated table, we are just going to put all these values in this table. Okay, so as we have calculated the different level at which we are just going to find the value of f. Okay, so for the as we have let me show you the previous here you can see that for the level of 0 to 10 meter. Okay, for the height level of 0 to 10 meter, the value of f is 7.902. Okay, So from the previous table, as you can see that the value of loading level, that is for 30 meter, for the maximum height of 30 meter, the design force value, that is F, the value is 10.722. Okay, so from here you can see that we are just going to put the value of F is 10.722 directly in this table. So now what we are just going to do here is that we need to find the value of 27th level, because we know that uh, if the value of 27th level, it would lie it would be lying nearly somewhere here. Okay, so we know that at the level of 20 meter, the value is 9.734. Okay, 9.3734, but after that it is continuously increasing. So here you can see that the maximum height level, I mean to say it's 30 meter, the maximum height level is 10, the value of F is 10.722. Okay, the value is 722. So and for 20 meter it is 9.734. It means it will definitely lie between the value of 9.732 and 10.722. So we are just going to interpolate this, and for interpolation I am just going to show you a picture where you can see that how we interpolate the values. So for interpolation, here you can see that now I have taken, because the value of F at 30 meter, we know the value already. Okay, for a level of 30 meter we know that the value is 10.722. So and we are going to find the value of F at 27th meter. Okay, and 20 meter, which we already know the value which we have previously calculated, that for a level of 20 meter the value of F is 9.734, and we have to find the mid value, I mean to say the in between value of 20 and 30 meter height. So now using interpolation, what we can do here is just directly applying the formula. Okay, you can directly apply the formula here. These are the uh, values of different constant which I have already mentioned here. Okay, so y1 would be 10.722, and y is the unknown value that we are going to find at the 27th level. Okay, so 9.734 is the value of y2. See, similarly for x1 it is 30 meter. Okay, for x1 is 30 meter, for x27 and x2 it is 20. So now putting all these values in this formula, you would be able to find the value of y at 27 level, 27 meter of height, that would be 10.4256. So now again here you can directly put this value at the level of 27. So remember, we have to find the value of maximum. Okay, we have to find the value of maximum range which we are just getting. Okay, now we will directly put the value of y that we have find. It means the value of F at 27 meter, that is 10.4256. Okay, after that again we will just put this value in our table which we have drawn here. So now again our value at 24 or 27th level, it would be 10.425, which we have calculated in by the method of interpolation. So now again what we are going to do here is the maximum height is 24 again. So again we have to just interpolate. Here you can see that I have interpolated some of the values which are useful for us. So here you can see that it will help you to find uh, the value of F. Okay, so at 27th meter height the value of 10 value will be 10.4256. At a level of y at the 24, it means the value of F value of f at a level of 24 meter and the value of f at the level of 21 meter. Okay, so these are the value which I have calculated for you with the help of interpolation. Okay, so you can directly put these all values in this table. So similarly I have find, but here you can see that for the level of 3 to 1, because these have a constant level of force. Here you can see that this is a constant level because there is no increase or decrease in this level. So you can just directly put the value of that is 7.902 for the height level of up to the height level of 10 meter. So as according to our chart here you can see that our height level is 0.3 and then 3 to 6 and 6 to 9. So there's that because these all lie under the value of 10 meter, so you can directly put the value of f is 7.902. Okay, so as we would be able to find all these values. Okay, what we are going to do here is now we will multiply the value of design force by uh, the loading levels. Okay, difference of loading levels. So we would be able to find the value at each story level, the total force our building is going to experience at each story. So here you can see that for the particular 10th story, uh, for the particular 10th story, the value of force, the total value of force at each story is, so by multiplying the design force that we have find, okay, multiplying by each level, that is each loading level, we would be able to find the total force at each story which our structure is going to experience. So it means at the 10th level, 10th story, our total force is 32.166. Okay, so we are just going to do this with each and every story here. So again, this 10.425 multiply by 3, because we this force we have calculated for a particular height, but we need to because we know that for in ninth story there are three loading level. Okay, so three loading level, that is the difference is 3, you can see. So for each and every level we need to calculate the total value, so that's why we are just multiplying it by 3. Okay, so further we will be calculating the value same as the way we have done in the step 1 and step 2, and for different story and different loading level you would be able to find the value of force. So after finding these force, okay, so the value which you find for the force for each story level, these are the forces for each story level. So with the help of this you can make a diagram. Here you can see that I have made for the story for this you can just draw a simple line. Okay, and draw these story levels. These are the story levels. Okay, and for each and every story, the force that is experienced by the story, these are the values which these are the values which we are just going to put. So with the help of these forces at each story level, okay, these are the values. So we are going to make our diagram. Okay, so this is the end of this question. I hope you find it important or helpful for your preparation. Thank you.